Recording in.
And so you guys can do your presentations now, so go ahead, Jake. Okay, so my name is Jake Stewart, and today I'll be walking you through my neural net for classifying wine quality. And first, I'll walk you through my data set. Let me share my screen first so you can see. Okay, so this is the raw data set straight from Kaggle. It's got 12 features. I'm not going to walk you through every single one of them. I'll expand them so you can see. We have fixed acidity, volatile acidity, citric acid, chlorides, residual sugar, free sulfur, total sulfur, density, pH, sulfates, alcohol, and quality, as well as type of wine, white or red. Our target feature here is quality, and as it's currently set up, it's not set up for a binary classification. Currently, it's set up, the users rated the wine on a scale of 3 to 9. And so in order to make it a binary classification, we had to make a boundary, and I set that boundary at 6. So if the wine quality is greater than 6, then it's a good wine. If it's under 6, then it's a bad wine. Other than that, the only other column or feature that needed transforming is type, and it's not numerical right now, so we had to make it numerical. So instead of type, I had it set up as is white wine, and then another feature for is red wine. And those values were either 1s or 0s for whether it was white or whether it was red. And like I said, this is the raw data set. The one where I transformed it is in here. So you can see where I made those adjustments here. The data set has 6,500 samples, and it's an imbalanced data set. So about 4,000 of those wines ended up being bad, and 2,000 of them ended up being good. Or I'm sorry, I got that backwards. 4,000 wines were good and 2,000 wines were bad. And that's as far as I went as far as cleaning and transforming the data set. And we can get into the model and the architecture. At first, I tried several things and wasn't able to achieve over 80% accuracy. I tried different optimizers. I tried raising the number of epochs and still wasn't able to achieve anything. But I saw a reasonably large jump in metrics when the number of layers increased from 4 to 7. And after I gave the first layer 50 nodes, I saw an even greater jump in the performance metrics. And we can get into the model now. I'm not sure why that happened. I had the file opened up and it gave me a permission error, but now the neural net's running. And as we go through it, one of the bad things that I noticed about my model is that the validation metrics are much lower than the test data or the training data set. And as far as I know, that means that the data sets have a big difference between the two. I tried different random states and I tried different epochs, and the validation data set metrics were always lower than the training ones. About 10%. As we get to the end, the training set should be around 90 to 93, and the validation should be around 77, 78. Yes. Yeah. Yeah. I did not find the F measure on.
You could have just used the sklearn function. That would have worked. But you just need predicted and the real. That's two vectors, and then their inputs to that function.
Yeah, I just didn't include it.
So that's an important metric to have whenever you have imbalance. It's very accurate. Remember the terrorist example I gave, right? 99% of passengers are not terrorists. So you build a classifier, it's going to say 99% accurate, but that's not true for finding terrorists.
Accuracy is not always the best measure when your data set's in balance. That's why we want to use multiple ones. And after the 200th epoch, it's fully trained, and these are the metrics.
Hard to read, actually. Oh, that's better. Highlight it.
Yeah, sorry.
Your accuracy is 74. Precision. Oh, you got precision and recall.
Yeah.
That's 86, 71, right? Validation.
Yeah, 86 and 71. And I made note of that in my report.
Still not terrible.
Since the data set is in balance, we will use multiple metrics to evaluate the model. But outside of that,
I have another question. Did you normalize the data?
Yes. So some of the features were like decimal values, and some of them were tens or even in the hundreds. And so I had to, yeah, in the data or in the, okay, all right.
That's important. I mean, I'm just trying to like things that you do normalize the data.
Yeah, I did normalize it. I did feature ranking. I can show that next if you'd like.
Yeah, we'll ask questions.
I've been having a problem with Weka since the beginning of the semester and have had trouble loading CSVs in there. So I tried to find an alternative, and I think I found one in TensorFlow that can do it within the conda prompt itself. And I did that in a separate file.
That I've actually always just used Weka, so I'm very interested. Did you guys set up GitHubs for this?
No. I can post it on. I'll post it on mine.
Great. Go ahead. Do you guys have GitHub account?
I do, but the one that I have isn't like under like it's not like a real professional. It's just
yeah. Create a GitHub and or use that one. Post your project.
I used Matplotlib to visualize the feature ranking. So once it loads here, it'll, and I'm not totally sure if it's right, because one, I get this warning from the conda prompt about wrong size input. But it, but it spits out the values as far as feature ranking goes, and it looks right to me from Matplotlib's chart here, bar graph.
It would have been good to run this in Weka and see if they are similar, then you would know. But you can't run it on Weka.
No, all year long I've been having my.
So according to, so what is that value from 0 to 16?
I'm not sure what the value is, but I do know that alcohol is the greatest feature as far as classifying the wine goes.
Volume of alcohol, quantity of alcohol. What do you mean by alcohol?
Probably. I'm not sure.
So you're telling me that people go back to that. You're telling me that people rated the wine in quality, and basically at the end of the day, it just translated to how drunk they could get.
That's what the graph shows. That's what the data suggests.
So this tells me that these were not exactly experts in wine tasting, but just regular people.
Yeah, I'm not sure who the users are that
like
where the data
set
came
that
from.
you collected, it's ratings, right?
Yeah,
I was under the impression that it was like, what are they called? Connoisseur.
professional wine tasters.
Whatever. They have they must have a name.
Yeah.
Well, no, they have a specific name, I think, for that. I think it's a job. But I thought that's what it was. But I wouldn't think that those people would rank alcohol as the most highest contribution. So this is obviously the regular.
Well, I'm not sure if they said that that it was good because the alcohol was so high. I just think that they rated it based on all that put together.
No, right. But if you're telling me that the high, it's like a very solid, much higher actually.
Yeah.
It's a very solid indication that they are basically had a few glasses of wine, and then they said, "Oh, this is the good stuff." Okay. So it's fixed acidity, sugar, volatile acidity, density. Density is like taste, I think. Sulfur dioxide. Interesting. Can you show it? Well, finish your presentation, but then I'd like to see the code that you use for this.
For the feature ranking or for the? Okay.
Well, all of it, but in particular this one.
Sure. Yeah. I'll just go through the rest of my report then.
Yeah. Finish the. So were you comparing white wine to red wine?
The two wines the two types of wines that were tested were white and red. But the target feature was the quality.
Like for instance, for each wine,
Whether red wine was better than the whites.
Yes, and what and why?
I did not know.
Good have, right?
Yeah.
That's kind of a thing that you. That's the point I'm trying to say. It's like data science. The whole point of applying data science or data science is that you guys can actually. It's not just about. Right? You can learn things. You can tell people things. Does that make sense?
Yeah, I could have taken it a lot further.
No, I'm just saying. Think about it. So that's the whole. Data science. You could say something about white wine now, red wine, marketing. So the marketing campaign will jump on, it'll get you really drunk. Yeah. Right? And sell you that product. So a lot of the time they just want knowledge. All right, yeah, keep going.
Other than that, I mean, I can open it up to questions right now.
Oh, okay.
That's about all I got other than the test that I did.
Okay, so I want to see the architecture. We talked about them, but can we take a look at that feature ranking code?
Yeah, we can.
And your background is dark?
Yeah. I'll find a way to change that. Or perhaps now might not be the best time.
Feature importance.
Trying to blow it up.
Why do you have X and Y from the same? You know that you have PD reads CSV?
Yeah, this is FRX, this is FRY.
Oh, I'm sorry. Yes. All right.
And
then selected.
the top 10 features. And what was left off was is red and is white. If we go back, if I run that just very quickly, if I run this again.
Yeah, but let me see here. So extra trees classifier. What is that for?
That was the class within sklearn that provided that functionality. It might have been available in
other classes?
yeah, but
you just found it in this one?
yeah, yes.
Okay, so create a model, you did it, X and Y, and then from where in model dot feature importance, and that's basically the thing that it prints that list of value, and then you just plot it.
Yeah.
So it's got, so basically the sklearn has a built-in feature for models called feature importances that allows you to do it. I didn't know that.
That's what I've been trying to say.
That's what you think.
Yeah.
Okay.
And here's my architecture.
This is the sklearn code.
Yes. Originally, I only had a handful of layers, but as I added a new one each time, I saw a slight increase in performance. And as I got up to here in 55 and 40, I saw an even bigger jump in performance metrics compared to the smaller jumps down here.
So you started kind of small.
Yeah, I started with 12 nodes,
How many layers?
4.
And that didn't work.
No, I was getting like 70% accuracy, slightly better precision.
You just gave it more layers and bigger, more norm per layer.
Yeah.
Binary problem. So yes, we had a 2-class problem. Reported accuracy. See, there you could have added F metric. And then you did fit, trim. How did you scale? Where did you scale the data?
Right here.
Oh,
Using
can
this,
you go to the top of the code? You converted the word to numbers. Then you did the train test split. Keep going on. Standard scalar. X train scale X. Fit on X train. Why didn't you? Oh yeah, Y train. X test scale. Y test. What is the? Where is the learning rate?
No, it's default. Yeah.
That's it.
That's it.
Good, good, good. Guys, do you have any questions for Jake?
No, I was really impressed with the beach tank.
Thank you, Lynn.
That one. All
All right, David, do you have any questions? All right, great job, Jake. Thank you very much.
Thank you for this.
So Lenny, you want to go next?
Yeah, is there a spot up there? Can you charge my laptop?
Yeah.
There is. Yeah.
Oh, it's- Hi, my name is Leonard Lynn, and I'm doing my presentation today on the Titanic dataset. I got it off of Kaggle. First off, I'd like to start by going over my code. I import these different libraries over here. I wanted to use some charts, so I used matplotlib and cblin. So down here, I guess it'd be better to show over here. It'll look clear on the actual notebook. So this is the data, this show who survived and who did not make it off the Titanic. The 1 means they survived, 0 means they did not. So roughly 300 people survived. And this shows the ratio, and it shows the ratio of males to females who died, and it shows that more males died than females overall. This chart here shows passenger class, and it shows that more third class passengers die than any other class of passenger. The challenge with this data set was cleaning it because of how, well, sorry, how old it is. We need to get it cleaned and usable for our modern machine learning methods. So first, we start off by dropping data that doesn't help predict whether someone particularly lived or died or not. So we dropped the cabin. I also did a change gender. Just remember we talked about the male and the females. I changed up grouping it into just sex, and that made it way more consistent. I used to get like 80%, 85%. Now I'm just getting 85% each time I run. So it's a lot more consistent. So next, we want to drop unnecessary titles and just make them more common. So Mr., Miss, Mrs. for younger gentlemen, Master, and all the other titles that were more rare, like Lady or Major, for example, we group those as rare. Over here, I bin the different data sets to make it more usable and easy for the machine to understand. Without binning the data sets when I ran it, I got values that were incredibly small. And that didn't work whatsoever. And at the end of the day, this is what our data set looks like clean. So this is what it looks like without being cleaned. This is the test data set. Now this is the test data set. This is the test data set when it's cleaned right here. Passenger, passenger class, sex, age, their fare, where they embarked, whether they were alone or not, and then their specific title. Next, we're gonna use, I use TensorFlow to classify. It'll predict whether they lived or died or not. Now, I found ReLU to be, although it's more accurate, it wasn't as consistent. Like I might get 87, 88, but sometimes I wouldn't even get 85 when I run. I found Geller's a little more consistent. So when I run it, it should end 85, maybe even 86. That's rare. Very rare. It looks like we're gonna end it in 85. So we got 85, accuracy. And
That's
here,
what the train-
yes. And this is I used sklearn to get the different metrics from it, test statistics, as I would call it, We have an F score of 80, a recall 76, accuracy 85.97, and a precision of 85.11. And here is my report. I documented all the code right here in the test metrics, which I'll make it easier to read later. But feature ranking, I did a feature ranking off Weka. I was lucky enough to get Weka to work, but I found that the two most important factors, according to Weka, after I entered the clean data sets were your sex, whether you're male or female, or whether you came alone. And those are what were found to be the most impactful features to the determining whether you survived or not. And that's my presentation.
Yeah, can you go, there's something odd in your, you have X train, Y train, X test, but you have no Y test.
No Y test? I did not have a Y test.
How did you measure performance? Because usually with train,
Mm,
you're gonna do the fit on X train, Y train,
mm,
and then you're going to apply the model to X test, which will give you Y pred, and you compare Y pred to Y test.
yeah,
You don't have that.
no, I don't.
So go back.
To my code? Okay.
So see there in the metrics, go down in the metrics.
Mm,
You have there Y train and Y pred, and that should be Y pred, Y test.
mm,
So you can't compare and give it in the model predict,
mm,
you give it X train.
yeah.
So at least it's correct in the
Mhm.
sense that you give it X train and then the real labels for X train
Mm,
are Y train, which you are using, and then you're comparing it to Y pred. In that sense, at least there's not a error there. But
mm,
the metrics that you're reporting are metrics of the train set only. You're not showing how it performs on data it hasn't seen before. Remember, that's the whole point of X test.
right.
Scroll up a little. Wait, stay there. Go back down. Yeah, there. So here you do predict on X test, and those are the predictions, right?
Yeah.
But where's Y test so that you can measure performance?
I just didn't.
You understand what I'm saying?
Yeah, I see what you're saying.
Okay, go up a little. Stay there. Fit on X train, Y train. Correct. That's correct. That's fine. But the model here is only reporting. Scroll down again. Here, this is go down. And here, what you do is predict on X training. And then you compare it to Y. So the problem is the metrics that you're giving, precision, accuracy, recall, and F1 score, are only for the trains. Generally speaking, they're going to be,
For both of them.
they're just going to be for the train set. So really, the metric you need to provide is how it performs on the X.
Right.
Go up a little. The architecture, you have input is 7, 50, 35, 20, 65, 21. Binary cost entropy. So that, all right. Where do you normalize the data? Is that back normalized?
Yes. Yeah, right over here.
Go up a little. here. Trying to understand train data, test data. So you grab survive, train data survive. Survive axis one. Then you did the same for passenger ID. So why didn't you just put Y train there?
Is that because Y train would be the unclean data?
That's what I'm not following. What's the problem?
Because
Because you're using X test, right?
yes, X test is this data here that's cleaned up, but this is the Y test that's not cleaned up. So that's why we use X test, because it's the clean
But
data
it's
set.
all coming from the same file.
Yes, but
Let's just do it. Go to your code. Add a line there. Y test equal train data survive.
Y test, you said?
You can just copy like Y train, exactly that line,
Hmm.
paste it down, but change it to Y test. The data should be test data. Right?
Yeah,
Theory, that's so now print it.
got it.
Do the actual data in Y test. This should just be a vector,
Hmm.
right?
Yeah. Let's see, error. Well, that's because it's not there anymore, because it's dropped already. Now it should work. Oh. Key error. Self.
Survive should be in both, right? That's great. That's the whole point.
I think only the train has the survived or not.
Did you generate these Excel files?
Did I make these Excel files? No, I got them off Kaggle. You mean the clean ones?
What's in you understand the problem?
That it's not comparing to the original.
Well, it's not. You're supposed to train on the train data, but you pulled out a data set for the train. Go back to just print whatever's in Y test and remove that survive, which is assigned to test data.
Okay.
Print Y, not the shape. Print the whole.
Okay.
See, because it's print the other three.
Okay.
Like you did here. So print all four.
Okay.
Leave that one. We're in a class. Yeah, we're in a class.
Yeah, do you mind if you utilize the preceding project, you utilize some of these desktops?
You can sit in. You can, hey, you can sit in. That's fine. But just be quiet. So you printed all four?
Yeah.
So X train, then Y train, which one is survive?
Under X, the third one, X test.
Yeah, so that's kind of the problem you have with the data. You have like inconsistent data,
Yeah.
but I mean, for my purposes, it's fine, but I'm just saying if you're doing this for real, you have to be
Using consistent data sets.
more careful because you want to train on, train set, X train, Y train, and then the point is to build a model so you can apply it to held out X test, Y test.
Right.
My suggestion would have been here just to stay with the 417 that have a survive,
Mm.
split that into 80% train, 20% test,
Mm.
train on the 80%, evaluate the 20%.
Right.
You understand what I'm saying?
Yes.
So I would recommend that you do that for the report.
Mm.
But are you clear of what I'm saying?
So you're saying we need to add the survive to the test set as well. So they
If you
like,
don't have it, you seem to have it in X test.
yes.
So what you could have done is just take an X test and assume it's just X,
Mm.
and now split it
Mhm.
80-20% split,
Mm.
so that you can use 80% of it for training and 20% of it for testing.
Right.
Got it? Try to do this. Any other questions?
I do.
Yeah.
I have a question about your architecture.
Yeah.
I'm just wondering if you tried it, you tried setting it up in that in like the funnel shape where your largest layer is the first one and then it gets smaller and smaller until the upper layer. Have you tried it?
I did not try that. Is that something you think I should give a try? Big and they get smaller. Okay. Thank you for your suggestion. Should I stop the recording?
Anything else, guys? Yeah. Please stop.